Today will be the first day that we're going to talk about one-step equations, and we're going to break it up so that we only do one-step equations with addition and subtraction for now. It says, in order to solve equations, we must find the inverse operation of addition, subtraction, multiplication, and division. Today, like I said, we are only focusing on the first two, so I'm going to draw a line right here. We'll talk about the rest later. The inverse operation means the opposite operation. So the opposite of addition would be subtraction. And the opposite of subtraction then would be addition. This will come in handy to remember as we go through the step-by-step process of solving. So when we look at these first problems, our goal is always to get our variable by itself. So on problem A, don't get this A confused, that's just how I numbered or lettered them. So problem A, we have x minus 5 equals 10. Right now, if you look at the side of the equal sign, the left-hand side, it's connected to a number by subtraction. So right now we have x minus 5. Our goal is to get the x by itself, so we want to undo that minus 5. To get rid of the minus 5, we're going to add 5 to both sides. Remember, in order to keep an equation balanced, we have to do the same thing to both sides. You'll notice that the minus 5 and the plus 5 are opposites. I put an O around them for opposites, and it also could serve as a 0 because it gives us 0. Then I bring down what I have left. I get x equals, and 10 plus 5 gives me 15. Now I understand that some of these are fairly simple and you probably could do them in your head, but I want you to get through the process of showing your work because you're going to need it later on in today's lesson. Now the best part about one-step equations is you can always go back and check your work. Since I said that x equals 15, I'm going to plug the 15 in up here and check. Does 15 minus 5 equal 10? And yes, it does. So now I can go to problem B. On problem B, you'll notice that I have a plus 9 connected to it. I'm going to have to do the opposite of that to get rid of it. So to get rid of a plus 9, I'm going to subtract 9 from both sides. A plus 9 and a minus 9 gives us 0 because they're opposites. And I'll bring down what's left. I end up with y equals, and 15 minus 9 gives me 6. To check over my work, I'm going to plug this 6 back in. 6 plus 9 gives me 15, and that's a true statement. So now I'm coming down to problem C, and you'll notice I have a variable on the left-hand side connected to a minus 8. To undo minus 8, I'm going to have to add 8 to both sides. The minus 8 and the plus 8 give me 0, and I get m equals negative 14 plus 8 gives me negative 6. If I were to plug it back in to the top, I'd get negative 6 minus 8. I'd keep it, change it, flip it, and negative 6 plus negative 8 does give me negative 14. On problem D, I want to undo a minus 8. To undo a minus 8, I'm going to add 8 to both sides. The minus 8 and the plus 8 give me 0 because they're opposites, and I'm left with A equaling 18. If I plug that back in, 18 minus 8 does give me 10. You'll notice that on these particular problems, the variable is always on the left-hand side. I want you to realize that it's not always going to be on the left-hand side. So I'm going to kind of sneak in an extra problem here. I'm going to just change this one around. So instead of y plus 9 equals 15, I'm going to put 15 equals y plus 9. Remember, we're always looking to the side that has our variable. So in this case, I'm looking to the side that has my y. In this case, I've got to get rid of the plus 9. And in order to get rid of that, I'm going to subtract 9. which gives me opposites, and I'm left with y equals 6. No matter which direction it is, I end up with the same answer. Some of you may want to rewrite it so it looks like question B if it were written this way, but it's up to you. Here we've got a couple more practice problems that look similar, but they are slightly different. So on problem A, you'll look to the side with our variable. You'll notice we have a plus 5. In order to get rid of that plus 5, I'm going to put a minus 5, which are opposites, and since I did it to the left side, I also have to do it to the right-hand side. That leaves me with x equaling 5. If I want to check over my work, I'm going to plug it in, and 5 plus 5 does equal 10. On problem B, when I look to my variable, I've got a minus 9 attached to it. To undo a minus 9, I'm going to add 9 to both sides. Since they're opposites, they give me 0, so I'm left with y equals 24. I'm going to plug it in to see if that works, and 24 minus 9 does give me 15. On problems C and D, you'll notice that we have adding a negative number. We want to make sure that when we're getting rid of this, we are creating opposites. Since they're connected by addition, we want to create opposites, and the opposite of negative 8, or a minus 8, would be a plus 8. Remember, when we circle that O around them, we want them to be opposites. So a minus 8 and a plus 8 gives me 0. So I'm coming to the other side to add 8. So I am left with m equaling 14 plus 8, which gives me 22. If I plug that 22 back in, I get 22 plus negative 8. They're different signs, so we subtract, and we do get 14. On problem D, again, you'll notice that we have this negative number. We want to create opposites, and the opposite of a minus 8 is a plus 8. So I'm going to add 8 to both sides. This O is for opposites. They give me 0. And A is going to equal negative 10 plus 8 gives me a negative 2. If I plug that in, negative 2 plus negative 8 gives me negative 10. And it checks out. The process does not change if we have fractions. It does not change if we have decimals. We still go through the step-by-step process. We want to get the x by itself. And remember, you don't need to be alarmed by the decimals or the fractions because you have your calculators and you are allowed to use those. So, on this first one, you'll notice that x is connected to a minus 6.5. And in order to undo a minus 6.5, I'm going to add 6.5 to both sides. The minus 6.5 and the plus 6.5 give me 0 because they're opposites. And x equals, I've got to do negative 9.3 plus 6.5. They're different signs, so I actually ended up subtracting. I get 2.8, and since there are more negatives than positives, my answer is negative. If I plug it back in, I'm going to actually just write it down below. Negative 2.8 minus 6.5. We have to keep it, change it, flip it. That does give us negative 9.3. So it does check out. Question B is where a lot of students end up making mistakes because they want to get rid of this minus 1.43 by putting a minus 1.43 on both sides. But what I want you to notice is that what's in this O is not opposites. In order to get rid of it, you have to create the opposite of a minus 1.43, and the opposite would be a plus. So to both sides, we have to add 1.43. In this case, we've got to add 0.89 plus 1.43, and that gives us 2.32. negative 1.43 plus 2.32 does give us 0.89. So it does check out. These are very similar in that we're trying to get our variable by itself. To get rid of that minus 3.5, I'm going to add 3.5 to both sides. Since they're opposites, I put the 0 around them and I get x equals. Now I've got to do my negative 9.2 plus 3.5, and I get a negative 5.7. They were different signs, so we did have to subtract. I'm checking over my work. I'm going to keep it, change it, flip it, and negative 5.7 plus negative 3.5 does give me negative 9.2. On problem B, again, these ones you want to be careful with because we want to create opposites. The opposite of a minus 1.2 is a plus 1.2. So I've got opposites. When I look in that 0 or O for opposites, they need to be positive, negative, however that goes. Now I've got W equaling 2.1. Negative 1.2 plus 2.1 does give me 0.9, so it does check out. Now these are the problems that I do not want you to be alarmed by. I want you to stop and think about the process yet again. So when I look here, my M is connected to a minus 5/8. In order to get rid of a minus 5/8, I'm going to add 5/8 to both sides. A minus 5/8 and a plus 5/8 are opposites, so they give me that 0. And M equals, now 3/8 plus 5/8 gives me 8/8, which is the same as 1. If I plug that back in, 8/8 minus 5/8 does give me 3/8, so that does work out. Problem D takes a few more steps, and we're going to go through those right now. So when I look at my variable, you'll notice that it's connected to a plus 2 over 12. Well, to undo plus 2 over 12, I'm going to do minus 2 over 12 to both sides. I'm going to put a 0 around this. I'll bring down my y, and I like my subtracting fractions written horizontally, so I'm going to just take this off to the side and write what we have. We have 5/9 minus 2/12. And our rule is, if you remember back to the song, we said, when adding up or taking away fractions, don't be a hater. Bottom numbers gotta be the same common denominator. So what we need to find is a common denominator between 9 and 12. That common denominator is going to be 36. So I'm going to have something over 36 minus something over 36 equaling something over 36. To get from 9 to 36, I multiply by 4, so I'm also going to do that on the top to give me 20. To get from 12 to 36, I multiply by 3, so I'm also going to do that on the top to give me 6. So now I have 20/36 minus 6/36, which gives me 14/36. Now 14 over 36 can be reduced, and it reduces down to 7/18. So I would accept either of those. Because the directions do not say to put it in simplest form, I would accept it in unsimplified form. If we wanted to back up and check our answer, I would have 5/9 equal to 7/18 plus 2/12. The common denominator between all three of these is 36. So for the 12, we're multiplying by 3. For the 18, we're multiplying by 2. And for the 9, we're multiplying by 4. And 20/36 is equivalent to the 14/36 plus 6/36. We're going to try another fraction problem. So when I look at C, you'll notice that there's a minus 1/8 attached to our variable. To get rid of that minus 1/8, we're going to add 1/8 to both sides. The opposites give us 0. And negative 3/8 plus 1/8 gives me a negative 2/8, which reduces down to negative 1/4. If I plugged that in, I'm going to use the negative 2/8. Negative 2/8 minus 1/8 is equal to negative 3/8. You'll notice because we keep it, change it, flip it, and then that gives us our negative 3. For problem D, we're going to go ahead and get our y by itself by creating the opposite. The opposite of a minus 2/3 is plus 2/3, so I'm going to add 2/3 to both sides. Again, I like to write it horizontally, so I'm going to write 5/9 plus 2/3 over here. My common denominator between the two is 9. So I just multiply by 1 here, which keeps it at 5. I multiply by 3, which gives me 6, so I end up with 11/9, which is the same as 1 2/9, because 9 goes into 11 one time with 2 leftovers. The most challenging type of problem that you would have with these one-step equations is where you have to set up the problem yourself. This says 23 minus a number is in math means equals 42. Since we don't know this number, we're going to call it n. So now we have our problem. Just working on setting it up. On the next one it says a number, we don't know what it is, increased, going up, by negative 45 is equals 77. We're going to talk about how to find those numbers next time. If you have any questions, please email me. It's sullivana@milton.k12.wi.us. Do your best to solve your classwork, and if you have questions, I'll answer them when I come back.